9-1. So on the previous lesson, we talked about how we find the vertex of a quadratic function by using this formula, the negative b over 2a, where the number in front of this is a, this is b, and this is c. Then to find the y coordinate, we just plug it into the function. The y-intercept is always that number because it is what you get when you plug in 0. So that becomes 0, that becomes 0, and it's your constant, whatever that might be. It's also a minimum or maximum value depending on if you have a sad face going down, so a is negative, or if a is positive, this would be a minimum value. Maximum value, minimum value. As high as it goes, as low as it goes. So today we're going to continue on that, and we're actually going to graph the functions ourselves. But we're going to graph them in a little bit easier using our vertex. So what we're going to do, we're going to start by finding out if it is a maximum or minimum by identifying the a as positive or negative. Then we plot that point and our axis of symmetry, and then we really only need to plot about 2 points after that. So let's get down to it, all right? So we are starting for this lesson on the top of the second page. So right up here, sorry about that. So we've got this. Here's our function, f of x equals x squared minus 2x plus 5. So first we want to consider, is it going to be a minimum or a maximum? Well, I know that a is positive, so it's going to go like this, meaning my point will have to be a minimum, because it's a minimum if a is greater than 0, and it's a maximum if a is less than 0, because then it's being positive or negative. So right here, since this is a positive a, it's going to go open upward, which means it is a minimum value. And then I want you to find the value. So we are going to start with finding x. So x equals a negative b. So we got negative 2 over 2a. So guess what? We have a positive 1. So if x is 1, then y becomes whatever we get when we plug 1 in. So 1 squared minus 2 times 1 plus 5. So y is 1 minus 2 plus 5. Or y is 4. So our minimum value is y is 4 because our vertex is 1 comma 4. And then the domain and range, and we talked about this a little bit, the domain would be all real numbers. Oops, I should write D for domain. And the range, the value of y, if this is the minimum value, it cannot be any lower than that. So y has to be greater than or equal to a positive 4. So there you have it. That's our first one. So let's move on. Let's do another example. This one I actually gave you this over here. Hey, A, B, and C. A is negative 2, B is negative 4, C is 6. So notice A is a negative 2. That means that baby's going to look like this. So we have a maximum value. It's a maximum. We are going to find it. I'm going to start right here and find x, which is negative b. So we got a negative 4 over 2a. So I got negatives all over in this. So be careful. This becomes negative 4 over negative 4, which is 1, but that negative out front makes it negative 1. So now when we plug that into our equation, y equals negative 2 times negative 1 squared minus 4 times negative 1 plus 6. So this is 1 but negative 2. This becomes plus 4 and plus 6, which means y is a positive 8. So there is our y coordinate, making our vertex negative 1 comma 8. And our domain is, as always, all real numbers. And our range is going to be y must be less than or equal to 8, because this is as big as it goes, as maximum. So it's got to be less than that. Okay, so now that we've learned how to find the vertex We learned way back when this was our axis of symmetry at the beginning of the lesson. We are going to graph it. So when we graph it, they kind of go through a couple steps. Find the axis of symmetry, that's that right there. Find the minimum or maximum point, which is the vertex. Then the y-intercept by plugging in 0 for x. And then we're going to use that line of symmetry and connect the points. Now I'll show you what that means. So we are now on page 4 of our notes. So check this one out. So A is 1, B is 4, C is 3. Let's find our axis of symmetry. So x equals negative B over 2A, which means we've got 4 over 2, which is 2, and the negative. So we've got x equals negative 2. That's our axis of symmetry. Guys, I'm going to come down right here, and I'm going to actually place my axis of symmetry on there because that's going to be very helpful in graphing my line, my curve, excuse me. Now let's go ahead and finish finding our vertex. In this case, we're plugging in negative 2. So we've got f of negative 2 equals negative 2 squared plus 4 times negative 2 plus 3. So be careful because that's a positive 4, but this is a negative 8 and a positive 3, which means our y value for our vertex is a negative 1. So we've got negative 2 comma negative 1, which incidentally would have to be a minimum value since A is positive. And I'm going to plot that point. So let's see, negative 2, negative 1, and no surprise, it is on my axis of symmetry. It better be. Okay, so now we're going to find the y-intercept, which means plug in 0. And it's really pretty simple. 0 squared plus 4 times 0 plus 3. You guys, it has to be 3. So 0 comma 3, because that's what our C is up here, because when we put 0 in, everything else goes away. So 0, 3, 1, 2, 3. Now, because this is the axis of symmetry, I know it's going to look the same on the other side. So it's going to go right here. So I'm going to graph that. Graph the vertex, the y-intercept, and the point opposite the y-intercept. And you know what? Just for the sake, because I'm kind of an overachiever, I like to try one more point. So I'm going to go ahead and put in negative 1 so that I can get that. So we got negative 1 plus 4 times negative 1 plus 3, which would be, 1 minus 4 plus 3. That's 0. So I got negative 1, 0, which means if I use that axis of symmetry. Now, do you have to put that actual point in there? No, but it definitely does make things a lot easier. And there you have your quadratic function. And we've graphed our parabola. Okay, so on the bottom of this page, general differences in linear, exponential, and quadratics. We're going to be talking about this more later in the chapter, so you want to take a look at that. That's great. You know, obviously, main point. Linear makes a line, exponential makes a curve, just a one-sided curve. Remember, it looks like this or like this. Parabola is symmetric, like this or like that, and we will talk more about what happens. But check this out, x to the first, x to the second, and our variable is an exponent on an exponential. So a couple main differences, like I said, we'll talk about that again later in the chapter. So moving on to the final page of our notes as we head into minute number 9 in my second video. So this is what we're going to continue. We're just going to do another example of this, okay? And we're going to do this with a word problem. Check this out. It says the cheerleaders at Lake High School launch t-shirts into the crowd every time the Lakers score a touchdown. Rock on. The height of the t-shirt can be modeled by the function, here, this should look familiar. We got that negative 16x squared where h of x represents the height and x is seconds. So we've seen this equation before, but we've used t instead of x. So just remember x stands for seconds. All right, so there's our function. Find the axis of symmetry. Well, first of all, A is negative 16, B is 48, and C is 6, which is going to be a little bit interesting. So finding the axis of symmetry, x equals negative B over 2 times A. So we have a negative, so we got negative 48 over negative 32. You guys, this is going to get a little messy. We will have a fraction, but never fear, we'll be okay. It will be positive though, so that's nice, but it is going to be, 6 over, so 48 and 32, let's reduce that. Oof, my brain is fried this morning. We can take out an 8 out of both of those, and I get 6 over 4. So yeah, it is going to be 6 over 4, then 3 over 2. That's 1 1/2. For right now, I'm going to leave it like that. I'm going to leave it 6 over 2 because it's going to be easier for me to find. So my axis of symmetry is 1 1/2. So right here is our axis of symmetry. Now, I have a sneaking suspicion I'm going to be changing my y-axis and going much larger since I've got some big numbers in there. So let's hold off on that. But let's find the vertex, plugging in 3 over 2. So this gets a little tricky. So check this out. F of x equals negative 16 times 3 over 2 squared plus 48 times 3 over 2 and plus 6. You are probably going to want to use your calculator, but guys, be very, very careful because this becomes a 9 over 4, which reduces that to 4. I'm pretty sure I get negative 36. This becomes 24, which becomes 72 plus 6. Just double checking my work here. I get 42. So 3 over 2, comma, 42. That, incidentally, is a maximum value because our parabola will go like this. So our vertex is at 42. Oh, eek. So probably going to have to go by something other than ones here. 5, 10, 15, 20, 25, 30, 35, 40. I'm going to go by 5s, guys. 10, 20, 30, 40, 50. All right. So 3 1/2, and I'm going to let these go by 1, so that's okay. And then we're going to go up to and plot my vertex, which is approximately right there, right? Okay. So now let's find the y-intercept, meaning if I plug in 0, look at my equation. If I plug in 0 there, the only thing I'm going to get is that, 6. So right here, it is going to cross at 6. All right. So if 1 is at 6, then let's find x equals 1. Let's do f of x 1. So negative 16 times 1 squared plus 48 times 1. Yep, and plus 6 gives me negative 16 plus 48 plus 6. So double checking that. I would hate to make a mistake. Yep, okay, just making sure. Is 38. So 1 comma 38 is another point. So approximately right here. Now, if I'm talking about the height of the t-shirt, because that's what H stands for, that's what our function stands for. This is the height of the t-shirt. It's going up and then it's coming back down. So if at 1 second, guess what? That's going to be here also because it's going to be symmetric. And then at 0, which would be the same as up here, that's also going to be 6. And there you have it. Now, I'm not going to extend it here because that's a negative time, which means something. That means something here. Okay, so make a smooth curve. We did. At what height was the t-shirt launched from? Check that out. That's what I was just talking about. At 0 seconds, it was already starting at 6 feet, because that's the y-intercept, which is 0, 6, so 6 feet. That's what it started at. All right. What's the maximum height? How high did it go? Well, what was our vertex? At 3/2 or 1.5x, y was 42 feet. So it was 42 feet was its highest point. And last but not least, when was the maximum height reached? And I hope that you figured that out. I kind of gave you a hint. It was at 3/2 or 1.5 seconds. So all of those pieces of information were pretty substantial pieces of information. We could also calculate approximately what time that t-shirt would have actually hit the ground, which would have been sometime after 3 seconds, probably 3.1 or something close to that. We could calculate that out. But that's, all that information. We do have a couple maybe word problems on your t-shirt worksheet. One word problem, but we're going to be identifying minimums and maximums, finding domain and range, finding the minimum and maximum value, which is always your y value of your vertex, and then graphing them. So that's all I got. Good luck. Come see me if you've got questions.